Hello guys, welcome to another video. This one is paper 2-3 of October-November 2018. This is paper 2 of course, and as always I will be doing this full paper question by question. I will try my best to explain as detailed as possible every single question. So let's not waste time. Let's begin doing those questions together. So question number 1, we have to solve this equation. Solving means to find the value of x. Now as you can see, on one side we have modulus and one side we don't. So in this case we have a few methods of solving this. One method is you can just square both sides and then solve, or you can just write this down as we have 5x minus 3 is equal to minus 3x plus 13. That is one of the possible solutions. Or we can have 5x minus 3 is equal to, minus will be outside, you will have minus 3x plus 13. That is, it will be the second option for your value of x. So let's solve one by one. So let's send all the x to one side. 5 plus 3, that will be 8x, is equal to 3 plus 13 plus 3, that will be 16. X will be 16 divided by 8, and that will be 2. Now here, same thing, we have to expand the bracket first. You will have 3x minus 13. Now send this one over here. You will have 5 minus 3, that will be 2. And minus 13 plus 3, that should be giving you minus 10, sorry. So x will be minus 5. So two values of x can be minus 5 or 2 for question number 1. That is one way of doing this. Other way is you can just square both sides and solve them one by one. Now question number 2, on each of the Venn diagram below, shade the region indicated. So we have A union B union C. So A union B, union C, prime will be outside. So everything outside of those three sets will be your answer. So you have this. So you just have to be outside of the three sets. That will be your answer for part 1. Now for part 2, here we have A intersecting B intersecting C prime. So let's do the first one. What is this one? A intersecting B will be B, intersecting C prime will be outside of C, so it will be only B but not C. Okay, that will be your answer for this one. Now for this one, let's do one by one. Here we have A intersecting B will be this one, right, the one in the middle, and the union C prime will be outside of C. So first we have to shade this one, and then union everything outside of C will be this one. So we'll be outside. So we have to shade everything. So let me first do this part, because we do have to shade everything else. So I don't know why I'm doing this, but I have to shade everything basically. So let's do this. Okay, here you go. Okay, so because C prime is everything outside of C, will be C is here, everything outside will be everything else except C. And then we have to union, which is N, the inside of A and B. So that's why you will have this shading, only these two is not shaded. That will be your question number 2. Now let's move on to question number 3. So here we have to write this in this form where A and B are constants. So let's do one by one. Let's first rearrange this. I will write this in this way: minus x squared plus 7x plus 8. Now I will rewrite this as minus x squared plus 7x. I will leave some space. I will write plus 8. Now let's factorize the minus outside. You will have minus 1 outside. You will have x squared minus 7x. Then we have to add a number. The number will be this number right here, which is 7. We ignore the sign, so you take 7 divided by 2 square plus 8. Now since you have plus something, you also have to minus the same number, so it does not change. Now we also, because it is inside the bracket for minus 1, we have to take out the minus 1 with it. Okay, now if you simplify, this will become minus This is x, here we have minus, and here we have 3.5, and that will be square. Then this will be plus 8, minus become plus 3.5 square. Now we can simplify one by one. So what is 3.5 square? That should be 12.25 plus 8. That should be 20.25. So your answer will be 20.25 minus x minus 3.5 square. That will be your answer for part A. So this is A. This is minus here. This is your value of B. So these two are constants, and this should be your complete square form for this equation. Now for part B, we have to hence state the maximum value of this one, and hence the value at x at which it occurs. Pretty easy. The maximum value will be this value right here. So you say max value will be the value outside always. It is 20.25 at x equal to. So to find the value of x, you have to look inside of this equation. So you take x minus 3.5, you equate that to 0. So x will be 3.5. So at the value of x is 3.5. Now for part 3, using your answer to part 1, so you have to use your answer from part 1, right? Solve this equation. So in part 1, you have something like this, which is 8 plus 7x minus x squared is equal to 0. Now if you want to compare, you will see that x here is just z squared, right? So it's almost the same thing, but not really, almost, right? So we know that this equation plus 7x minus x squared became 20.25 minus x 3.5 square. So what does this mean? This will become what? So by doing something very similar, you will see that the only replacement we make is that x is actually z squared. That will become 20.25 minus x will be z squared minus 3.5 square. So that will be using part 1. So now we know this become this. We have to solve, equate that to 0. Next step, we have to send this over here. You will have square minus 3.5 square equal to 20.25. So z square will be 3.5 plus minus root of 20.25. Okay, so what is that? That should be 4.5. So z square will be 3.5 plus minus 4.5. And finally, z square can be equal to two possible values from what we have seen. So one value will be 3.5 plus this. That will be 8. Or z square can be 3.5 minus this will be. So 3.5 minus 4.5 should be minus 1. So now this one will not be possible because it will not be a real value. Square cannot be negative, right? But for this one, as you can see, z can be plus minus root of 4. And that will be, sorry, 8, not 4, 8. Now this is your answer. You can always simplify this if you want to, because you know that root of 8 is actually equal to 4 times 2, which is 2 root of 2. So plus minus 2 root of 2. Or you can write your answers in terms of decimal as well. That should be okay. But that is your answer. 2 values of z for this question. That is your question number 3. Now let's move on to question number 4. So here we have d2y by dx2 is equal to this function. Now part 1, we have to find dy by dx given these 2 values. So how do you find dy by dx from d2y dx2? So we know this is equal to integration of d2y by dx2. So let's do that. You will be integration of 2x plus 3. Let's send this up. You will have x plus 1 power minus 4 dx. So 1 by 1, you will have 2x squared divided by 2 plus 3, and that will become x plus 1 power minus 3 divided by minus 3 times 1 plus c. That is, of course, dy by dx. Now we have to simplify. These two will cancel out, and this cancel out. You have minus here. You will have x squared minus x plus 1 minus 3 plus c. That will be your dy by dx. So next thing, you have to find the value of c by using these two values. When the value of dy by dx is 1, we know x is also 1. That will be 1 plus 1 minus 3 plus c. So these two will cancel out. So c will be 2 minus 3, which is 1 over 8. So finally, you have your value of dy by dx will be x squared minus 1 over x plus 1 power 3 plus 1 over 8. And that is your answer for part 1, to find the value of dy by dx. Now for part 2, we have to find y in terms of x for those values. So we have to find y. So same steps. How do you find y? Y will be integration of dy by dx. That will be integration of x squared minus x plus 1 power minus 3 and plus 1 over 8 with respect to dx, to x. Now, one by one, increase the power by 1, 3, divide by 3, minus x plus 1 power minus 2, because we have to add 1, and then divide by the power, and then plus 1 over 8x plus c, that is y. Now simplify. You will have y is equal to 1 over 3x cubed plus 1 over 2x plus 1 square plus 1 over 8 times x plus c. So we have to find this value of c again by using the given values. So y is 3, when x is 1, that will be 1 over 3 plus 1 over 2 times 2 squares 4 plus 1 over 8 plus c. So simplify. So we have to send everything over here. So 3 minus 1 over 3 minus 1 over 8 minus 1 over 8. That should give you value of c will be 2, 5 over 12 if you want to simplify. 2 times 12 is 24 plus 5 is 29 over 12. So finally, your y is equal to 1 over 3 x cubed plus 1 over 2 x plus 1 square plus 1 over 8 x plus 29 over 12. That is your value for your question number 4. Now let's move on to question number 5. Given that A is equal to this, to matrix, these two are 2 by 2 matrices. First one, we have to find A inverse. So A inverse, pretty easy, step by step. We have to first find the determinant of A. That will be cross multiply 2 times 4 minus 3 times 1. That should give you 8 minus 3. That will be 5. And what is the adjoint matrix of A? We have to change the position of those two. 4 goes up, 2 goes down, and change the sign of those two, become minus 1 and minus 3. So hence we have the value of A inverse will be 1 divided by determinant times the adjoint matrix. That will be your A inverse. So A inverse is simply 1 over determinant times your adjoint matrix. That will be part 1. Now part 2, the matrix C is such that CA is equal to B. So if you observe, you have to find the value of C. So CA is equal to B. So you have to eliminate the value of A. So you have to multiply by A inverse here and A inverse here. So this will become I. So you will have C is equal to B times A inverse, which is B is given to you by 1 minus 2, 4, 5 times A inverse, which is 1 over 5. We can we can put this in front. 4 minus 1 minus 3, 2. Okay. So one by one, how do you do matrix multiplication? You have to do rows by column. So this times this plus this times this. So 1 times 4 plus 4 times minus 1. That will be 0. Okay, that will be the first value. Now next value, same thing, rows by column. So 1 times minus 3 plus 4 times 2. That will be 5. And rows by column, minus 2 times 4 plus 5 times minus 1. That will be minus 13. And then you will have for this one, you will have rows by column, minus 2 times minus 3 plus 5 times 2. That should be 16. Okay, so that will be your value for C. You can just leave it like this, or if you want to bring this in, you can also simplify if you want to. But it's always best to double check those values because you never know. So let's say we have rows by column for this value. So 1 times 4 plus 4 times minus 1, that will be 0. Good. And then for this one, this by this, so 1 times minus 3 plus 4 times 2, that will be 5. Good. And this one, rows by this column, minus 2 times 4 plus 5 times minus 1, that should be minus 13. And this by this will be minus 2 times minus 3 plus 5 times 2. That will be 16. So that is good to go. Now for part 3, we have to find the matrix D such that A inverse times D plus B is equal to your identity matrix. Now we have to find D. We have to make this D subject of formula. So let's see what can we do. So let's do this on this side. You will have first A inverse D is equal to I minus B. So what is that? I is just 1, 0, 0, 1. Minus B is what? It is 1 minus 2, 4, 5. That should give you 1 minus 1 is 0, minus 4, that will be 2, and minus 4. Right, that will be this matrix. Now to eliminate A inverse, we have to multiply by A on this side. That will become A inverse, and then D. Here you will have A as well. A is equal to, from your question, is 2, 1, 3, 4 times this matrix, which is 0, 2, minus 4, minus 4. So this one will become I. It will go away. So finally, you will have D is equal to this multiplication. So always rows by column. So 2 times 0 plus 3 times 2, that will be 6. 2 times minus 4 plus 3 times minus 4, minus 20. 1 times 0 plus 4 times 2, that will be 8. 1 times minus 4 plus 4 times minus 4, that should be minus 20. So here you go. That will be your matrix D. By doing step by step, making this become your subject or formula, you will find this answer. That will be your question number 5. Now let's move on to question number 6. So here we have to solve the simultaneous equation. So let's see what do we have here for question part 1. So we have log to the base 2 here. We have 3. We can simplify this. We have log base 2. We have x plus 2y is equal to 3. That will give you x plus 2y equal to 2 power 3. Eliminate the log. You will have this, which is x plus 2y is 8. So x will be 8 minus 2y. That is your first equation. Then for this one, let's see what we have. We have log base 2, 3x minus log base 2y equal to 1. So first thing was we can combine these two together because they have the same log of base 2. You will have that. And then 3x minus is divided by y is equal to 1. Now same thing, simplify. You will have 3x divided by y is 2 power 1, which is 3x is equal to 2y. That is your equation number 2. Now we can replace this value in this x. You will have 3x will be 8 minus 2y is equal to 2y. That will become 24 minus 6y is 2y. That will become, send this over here, you will have 8y is equal to 24. So y will be 24 divided by 8. That should be 3. So x will be 8 minus 2 times 3. That will be 8 minus 6. That will be 2. So x is 2 and y is 3. Okay, so here you go. That will be your question number 6. Now 7, we have a squad of 20 boys, which includes 2 sets of twins. So 20 boys, 2 sets of twins. Okay, is available for selection for a cricket team of 11 players. So we have to choose 11 players for that team. But here we have 2 sets of twins. Okay, so first one, calculate the number of different teams that can be selected if there's no restrictions. So if there's no restrictions, we can choose anybody. So from 20 boys, we have to choose 11 players because the team has 11 players. So we have 167,960 ways of choosing them. That is the first one. Now here we have a condition. Both set of twins are selected. So for us to understand this, we have to break our group down into pieces. So we have 20 boys. We have 2 twins here. So sorry, 2 people, which is twins, and 2 people, which is twins as well, and remaining 16 people, if that makes sense, because they have 2 sets of twins. Twins is 2 people, so 2 sets of 2 people, right? 2 and 2, and then 16. Now both has to be selected. So from these 2, we select those 2, and then from these 2, we select those 2, and then from the remaining 16, we have to select. So here we have 2 plus 2 is 4. We have to select remaining 7 people to form 11 people. So 2 choose 2 times 2 choose 2 times 16 choose 7. That will be 11440. That will be your number of different ways of selection. Now let's move on to part 3. One set of twins is selected, but neither twin from the other set is selected. Okay, so we have to do the same steps. So we have 20 people, we have 2 twins here, we have 2 twins here, and we have 16. So we have to understand what's happening. So we have only selected one set of twins is selected, but neither twin from the other set is selected. So we have one options. So let's call this one twin of set, let's give it a name, twin set A, twin set B. So we have 2 cases here. Let's say we say first case, both twin in set A are selected, so we take 2, choose 2, and this one is 0. We don't take anyone from here. So from the remaining 16, we will take the remaining people, which is we need 9 people because we need 11 people in total. Okay, that will be one of the selections. So 2 choose 2 times 16 choose 9. That will be 11,440. Now next one, next option, we choose 2 of 2 from the set of B, and then we don't choose anyone from here. We choose the remaining from this one. That will be also the same thing. Okay, so you have to add both options to find your total number of ways, which is 22880. Okay, that will be your answer. So let me check something. 16 choose 7 is also the same value. Okay, good. So that will be part 3 of the question. Now part 4, it says exactly one twin from each set of twins is selected. Okay, so same steps. First, let's break it down so we can visualize. We have 2 twin from set A and 2 twin from set B, and then 16 people. So we choose 1 from this set and 1 from this set, and then 16 we have to choose remaining 9 people. So 2 choose 1 times 2 choose 1 times 16 choose 9. That will give you 45,760. Okay, and that will be your question number 7. Let's move on to question number 8. So here we have variables x and y are such that y squared is plotted against exponential power 2x, and a straight line is obtained passing through those 2 points. So now you have to understand what is usually a straight line equation. So you would know a straight line is something like y equal to mx plus c. This is when y is plotted against this one. But now, since we have y squared is plotted against this, so you will have to look something like this. Y squared is equal to gradient times exponential 2x plus c. So that will be your equation of straight line for this graph. Now we have to express y in terms of exponential. So we have to first find the value of m and find the value of c. M is your gradient, so m pretty easy. Since we have 2 passing points, we can find the gradient. So gradient will be y2 minus y1 divided by x2 minus x1. That will be what? 12.1 minus 5.5 divided by 3.7 minus 1.5. That will be 3. Okay, so now we have y squared is equal to 3 exponential 2x plus c. Now we have to find the value of c. So to find that, we have to use one of those points. We have 1.5 and 5.5. The first point here is exponential 2x, and here we have y squared. Replace back in our equation, you will have 5.5 is equal to 3 and then 1.5 plus c. So c has to be what? Let's check. 5.5 minus 3 times 1.5, that should be 1. So your answer will be, you will have y squared is equal to 3 exponential 2x plus 1. So y is root of 3 exponential 2x plus 1. That is your answer for y in terms of exponential 2x. Okay, that is part 1. Now for part 2, we have to find the value of y, 1x equal to this value. So y will be root of 3 exponential 2 times x will be 6 plus 1. So 3 exponential 6 plus 1 root, that will be 34.8. Correct to 3SF. Now for part 3, find the value of x when y is equal to this value. So we have this equation. So y squared is 3 exponential 2x plus 1. So 3 exponential 2x is equal to 50 squared minus 1, right? And exponential 2x will be 50 squared minus 1 divided by 3. And then you will have ln. You have to send this over here. You will have 2x is ln of this value. Okay? So finally, x has to be half of ln of this value. So let's find out what is that. 50 squared minus 1 divided by 3. That will be this value. Half of ln 833. So let's do the half of ln answer. That should be 3.36. So 3.36 will be your value of x, correct to 3 significant figures. And that will be your question number 8. Now let's move on to question number 9. So here we have to solve this equation for radians. Radians between 0 and pi. If you want to know, 0 is 0, pi is 180 degrees. So that is our domain. So we have to find the values of x for this domain. So step by step, the first thing is you want to make this become sine become the subject of formula. So you will have sine of the angle, which is x plus pi by 4 equal to root 3 over 2. Next step, since sine is positive, it will have to be in the first quadrant and the second quadrant. Okay, so this angle here will be x plus pi by 4 is equal to sine inverse of root 3 over 2. So let's see what we get. So root 3 divided by 2, we have sine inverse of that. That should give you 60 degrees, which is pi by 3 radians. Now also we have the other value, which is 180 degrees, which is pi minus theta, which is this value. That will be pi minus this will become 2 pi by 3. So now we have to find the values of x from this. So finally, x will be equal to this minus this will become what? So you have this minus pi by 4, but also 2 pi over 3 minus pi by 4. So 1 by 1. So we have 1 over 3 minus 1 over 4. That will be pi over 12. That is your value of x. But also this one is 2 over 3 minus 1 over 4. That is 5 pi over 12. That is your values of x. That is for part 1. Now for part B, we have to solve this equation for degrees now between 0 and 360. So let's simplify this one by one. So what is sec? Sec y is equal to 1 over cos y. What is cosec y? That is 1 over sin y. Let's replace. You will have 3 over cos y is equal to 4 over sin y. Cross multiply, you will have 3 sin y equal to 4 cos y. Now whenever you have sin and cos in one function, you just divide everything by cos y, and you will see you will have 3 tan y is equal to 4. So tan y will be 4 divided by 3, and since tan is positive, it will be in your first quadrant and in your third quadrant for your values of y. So y is equal to tan inverse of the value. So we have 4 divided by 3. Tan inverse of that should give you 53.1 degrees, but also should give you this one, which is 180 plus 53.1, that should be 233.1 degrees. And that is your values of y, 53.1 and 233.1 degrees. That is part B. Now let's move on to part C of the question. So how can we solve this one? So here we have 7 cot z minus tan z equal to 2 cosec z. So the first reflex is to simplify everything. Right, let's try to see what we can do. So cot z, as you guys know, must be cos z over sin z. Now tan z must be sin z over cos z. Now cosec z is 1 over sin z. Now let's replace the values back to your equation. You will have 7 cos z divided by sin z minus sin z divided by cos z 2 times 1 over sin z. So now we have to simplify one by one. So we can try to first simplify the left hand side. Let's see what happens, right? So I would say we can first send this over here, because if you observe, we will have something like this. You will have 7 cos z, now become minus 2, because they have the same base, it will become over sin z. And send this one over here, you will have sin z over cos z. So now we can just cross multiply. You will have 7 cos square z minus 2 cos z equal to sin square z. Now you guys must know sin square z is 1 minus cos square z. Simplify. 7 cos square z minus 2 cos z is equal to 1 minus cos square z. Send everything to one side. You will have 7 plus, when you send it will be plus 1, 8 cos square z minus 2 cos z minus 1 is 0. So if you guys are confused by this equation, you can always do let u equal to cos z. So you will have 8u square minus 2u minus 1 will be 0. So let's see if you can factorize this or not. We will have 4u times 2u. This is 1 times 1. To get minus 2, we have to have minus 4 plus 2. So yes, we can factorize this. So u will be minus 1 over 4, or u will be 1 over 2. But here we don't want to find u, of course. We want to find the value of z. Replace back. You will have cos of z is equal to minus 1 over 4, or cos of z is half. So here we have a negative value, as you can see. So the value of the angle should be in the third quadrant and in the second quadrant. So we have two values for the angle. Let's find one by one. So let's first find theta. Theta is not z, so it is just the angle we need to find to help us find z. That will be cos inverse of the positive value of 1 over 4. So 1 over 4. So we only do this when it is negative value, okay? So you will have 75.5. So now we have to use this and look at our quadrants to find the value of z. As you can see, z will be in your second quadrant, which is 180 minus this. So 180 minus 75.5. That will be 104.5. And then in your third quadrant, which is 180 plus this value, that will be 255.5. That is your value of z for this value. Now here, as you can see, cos is positive. It will be in your first quadrant and your third quadrant. Okay, I'm sorry, the fourth quadrant. So z will be cos inverse of half, which is 60 degrees and also 300 degrees based on your quadrants. Now finally you will have z is equal to 60, 104.5, 255.5, and 300 degrees. That will be the answers for question part C, and that is question number 9. Now let's move on to question number 10. The equation of the curve is given to you by this equation for x is more or equal to minus 3. That is a domain defined for your equation, for your function. Now we have to find dy by dx, so one by one. First, let's rewrite this down as y equal to x squared. What is square root? It is 3 plus x power half, right? So dy by dx is equal to, we have to use the product rule to do this. You will have, first remain the same, you have half times, so we have to times the d by dx of this one. 3 plus x, that will become minus half, and times 1. Then plus the second one will be the same, right? And then times the d by dx of this one will become 2x. Now simplify. This will become x squared will be on top, divided by 2 root of 3x plus 1. And then we have to write plus 2x root of 3x plus 1. So, so 3, it's not 3x, 3 plus x, my bad, 3 plus x. So let me rewrite this down. Basically, dy by dx will be x squared over 2 root of 3 plus x plus 2x root 3 plus x. That is part 1 of the question. Now let's see what else we have to do here. We have to find the equation of the tangent to the curve at the point this. So we have one point x. Let's find the point y. So y will be, replacing x in this, you will have 1 squared, 3 plus 1, that will be 1 times root of 4, that is 2. So the passing point will be 1 and 2. So we have to find the equation of the tangent at this point. So first, before you find the equation of a straight line, you have to first find the gradient of tangent. So gradient of tangent is equal to dy by dx at the value of x equal to 1. So replace back in your equation here. So that will be equal to 1, 2, root of 4 plus 2 times 1 is 2. That will be 4. So you will have 1 over 4 plus 4. That will be, if you want to make everything become 4, you will have 17 over 4. That is your gradient of tangent. Now to find the equation, we have to use this and the passing point to find the equation. So y minus 2 over x minus 1 is equal to the gradient. Now we cross multiply, that will give you 4y minus 8 is equal to 17 x minus 17. So 4y is equal to 17x plus, so minus 17 plus 8, that should be minus 9. So this is your equation of your tangent. That is your question number part 2 of question number 10. Now let's move on to part 3 of the question. So find the coordinates of the turning points of this curve. So you have to know turning points is the same as stationary points. So basically it is asking you for the stationary points. So we know this happens when dy by dx is equal to 0. So right now dy by dx is equal to x squared over 2 root of 3 plus x plus 2x root of 3 plus x is equal to 0. So now we can, if you want to eliminate this base, you have to multiply everywhere by 2 root of 3 plus x. So you will have on top here, this will be the same because we have this time this will be cancelled out, plus 2 times 2 is 4, x will be, and this time this will become this, and 0 times this will be just 0. So you will have x squared plus 12x plus 4x squared is 0. That will be 5x squared plus 12x is 0. Now if you factorize x outside, you will have 5x plus 12 is 0. Now x can be 0 and 5x plus 12 can be 0. X can be minus 12 over 5. That is your values for x. Now we have to find the corresponding values for y. So y will be what? Let's see. Y will be, we have x squared is 0 times something, that will be also 0. So turning point here, first turning point is 0, 0. Now this one, let's see, we have, so let's check. Minus 12 divided by 5 is minus 2.4. So the condition we had here is x has to be at least bigger than minus 3. So this is okay. So y will be equal to minus 2.4 square root of 3 minus 2.4. So you will have square that value, that will be 5.76 times this will be what? 3 minus 2.4 is 0.6. So 5.76 root of answer, that will be correct to 3SF 4.46. So we have two stationary points. The first point is this one, 0, 0, and then we have this one as your two stationary points, which is also called turning points. This is question number 10. Now let's move on to question number 11. A line with the equation y is a tangent to the curve of this. So tangent means it meets the curve at only one point, so which means we have to use b squared minus 4ac is equal to 0. But first we have to solve them simultaneously, because here we have y and we have y, and we know they meet at one point. So on one side you will have something like this, and then equal to this side 7 minus kx minus x squared. So now we have to bring everything to one side. You will have x squared plus kx minus 5x plus k plus 5 minus 7 is 0. So x squared will be k minus 5x plus k minus 2 is 0. So now if you compare, this is 1 here, this is your a, this is your b, this is your c. So we know that b squared minus 4ac, so k minus 5 squared minus 4 times a times c, which is k minus 2, has to be 0, according to the information given to us. Now we have to solve this. That will become k squared minus 10k plus 25 minus 4 times k minus 2. Simplify again, you will have k squared minus 10k plus 25 minus 4k plus 8 has to be 0. So simplify again, that will be k squared minus 10 minus 4 is minus 14k plus 25 plus 8 will be plus 33 is equal to 0. Now we can try to simplify, of course, factorize for the two values of k. K squared is k times k, and 33 is 11 times 3, right? So 3 here, that will be 11. To get minus 14, we have to do minus 11 minus 3 to get minus 14. Now k is equal to 11, or k can be equal to 3. So these will be the two possible values of k. Now moving on to part 2. For each value of k, find the equation of the tangent, equation of the curve, and the coordinates of the point of contact of the curve and tangent. Pretty easy. So when k is equal to, let's say, 3, equation of tangent was the line. You can see a line is a tangent, so this one is your tangent. So tangent was equal to y equal to minus 5x plus 3 plus 5, which was minus 5x plus 8. That will be your tangent. And curve, we just have to replace back in the equation of the curve, which is this one. It will be y is equal to 7 minus 3x minus x squared. That is your curve. Now last one is we have to find the coordinates of the point of contact between those two. So basically we have to solve them simultaneously and see where they meet. So according to the equation we had is until here. right? So that was, equation was x squared, so they meet at x squared plus k minus 5 is minus 2x, k minus 2 is plus 1 equal to 0. So let's see, what do we have here? So we have x squared minus 2x plus 1 is 0. So factorize, x is x squared is x times x, 1 is 1 times 1, minus 2 can be obtained by minus minus. So the point will be x equal to minus 1 and y will be replaced. So minus 1 plus minus 5 plus 8, that will be 3. So the point is 1 and 3. That is the point where they meet if k is equal to 3. Now, next part is, let's say k was equal to the other value, which was 11. Okay, so now for k is equal to 11, tangent would have been y is equal to minus 5x plus 11 plus 5, that will be minus 5x plus 16. Now the curve will be y is equal to 7 minus 11k minus x squared. Now they will meet according to the equation x squared, then we have to plus k minus 5 is 6x, and then k minus 2 will be plus 9 is equal to 0. Factorize, you will have x times x, and 9 is 3 times 3, plus will give you the value of 6. So x will have to be minus 3. And what is the value of y? Y will be minus 5 times minus 3 plus 16, that will be 1. No, that is not 1 actually, because here you will have 15 plus 16, that will give you 31. So the point where they meet will be minus 3 and 31. Okay, so that is the question for part 2. Now for part 3, we have to find the distance between the 2 points of contact. Okay, so pretty easy. The first point we have realized it was 1, 3. Second point is minus 3, 31. So distance, we can just use your formula given to you. You should know this. It is square root of x2 minus x1, that is minus 4, right? Square plus 31 minus 3 square, that is root of 16 plus what? 31 minus 3. 31 minus 3 squared, that will give you 784. So 784 plus 16, that will be 800. Now if you want to if you want to evaluate this, you can always do that. You will have 28.3 units. Or if you want to provide the answer in exact form, you can always write this down as 10. So we have 100 times 4 times 2, right? That will be square root of that. That should give you 10 times 2 times root 2, which is 20 root 2 units as your answer for exact value. This is in terms of decimal places. Okay, so that was the last question of this paper. I think so. Yep, the last question. I hope that was somewhat useful, and as always, thank you for watching. I will see you soon.